Alright, area of regular polygons using triangles other than special right triangles. So just to point out a couple of things for you before we begin, we are not using special right triangles, we're using triangles other than the special right triangles. And then another thing to review before we begin, what regular means. So the area of a regular polygon. Regular means all sides equal. So all the sides are equal in the polygons that we're going to be dealing with, and you'll see that in the examples that we're going to do in a little bit. First, though, let's review how we find the area of different, or how we find the missing sides of different triangles, of triangles that are not right triangles. So in the first box, we have the review of what it's going to take to find the missing side. So this is, remember, the side. This is what I do. The sine of x. So if I'm focused on this angle, I'm going to look to the side opposite, and I'm going to find its length, and then I'm going to look to the hypotenuse. And remember that the hypotenuse is always across from the right angle. So we would do the sine of x is equal to opposite over hypotenuse. Okay? If I were doing the cosine, I would be using the adjacent side over the hypotenuse side. And again, hypotenuse is always across from the right angle. And then if I'm doing the tangent, remember it's opposite. So if I'm looking at angle x, the opposite over the adjacent side. And so this is the hypotenuse side across from the right angle. There's no hypotenuse in the TOA, right? So I'm not going to use the hypotenuse side in the TOA. Remember, we talked about SOHCAHTOA. This is going to help you remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we'll need to remember those. The other thing that I want you to remember is that when you're looking for the missing angle, okay, you need to do the inverse of the sine, the cosine, and the tangent, okay, to look for the angle measure. So when you're looking for the missing side, you just simply do sine, cosine, tangent. But when you're looking for the missing angle, you have to do the inverse. That's why there's this little -1 that indicates that we're doing the inverse. And then you put the ratio opposite over hypotenuse in the parentheses, and you calculate that on your calculator. And what you get for a result is your degree measure of your angle. And just to note to self, we usually try to make sure that we use the calculator. Okay, I know that solving these without the calculator is a bit challenging. We want to make sure that we know how to do this, plug it into the calculator, know where you're going with it, and be ready to move. So I'm going to scroll the page, and we are going to begin with an example. The best way to do this is to just jump in and do an example. Once you do a few of them, they become a little easier. So let's start off with this. So to find the area of a regular polygon, we need the formula. Area equals 1/2 apothem times the perimeter. Now, in the last lesson, we did these exact problems, but we were using special right triangles. So the triangle that was formed had a 30-60-90 or a 45-45-90. These ones do not. So the problem tells me that my polygon is regular. That means every single side is 8. Okay? Every single side is 8. So if this entire piece is 8, I now know that this is 4 and this is 4. So that's some good information. I know the bottom of my triangle. But I have to figure out the angle. Okay? I have to figure out how much this angle is right here so that I can do sine, cosine, or tangent. All right, so I'm going to say that to find the angle, step 1 is going to be find my angle. And I do that by saying 360 degrees, because all the way around the outside of this, the whole revolution is a circle, 360 degrees. I'm going to divide that by the number of sides. Just like we did last time, divide by the number of sides. And there are 2, 4, 5 sides. So 360 divided by 5 is going to equal 72. And then we need to divide that in half. And this is the same as what we did last time. and that gives us 36 degrees. So this is a 36-degree angle, not a 30, 60, 90. Okay? That's a degree symbol right there. Okay? And the second thing we need is we need to be able to figure out the perimeter. Okay, so I have my angle. I need that angle to solve this triangle in a minute, but before I do that, let's do the perimeter. So 8, I need that 5 times. So 8 times 5, because that's the number of sides, equals 40. So the perimeter is 40. I can plug that into my equation. So I'm missing my apothem. And just like in the last lesson, when you're looking for your apothem, the first thing you do is find your angle measure. Okay, and then if you want to, which I always like to do, I like to redraw the triangle that I'm dealing with. So I have a 36-degree angle here, and I know that this piece is 4, and here's my right angle. So again, the apothem is that segment that starts in the middle of the circle and makes a right angle with one of the sides, perpendicular to the side. So that's the side that I need to find, so that's where I'm going to place my X. Now I have to determine which of my 3 trigonometric functions I'm going to use to help me find out what X is. So my choices are SO, CA, TOA. So I need to decide, what is it do I have? What do I have? So I have my angle, that's awesome. And I have the side that's opposite my angle. So this is the opposite side. And I know that this side over here has to be the hypotenuse because it's across from my right angle. So that leaves the X as my adjacent side. So I have no information about my hypotenuse, so I can cross it out. I have opposite and adjacent. So this one has a hypotenuse in it, so I can't use it. This one has a hypotenuse in it, and I can't use it because I don't have any information about hypotenuse. So I'm going to use the tangent. So you set up your equation like this. The tangent of the angle, so the tangent of 36, is equal to opposite over adjacent. And you're going to solve this exactly the same way you solved it in the last lesson. Okay, so you're going to put your tangent over 1 so that you have a proportion, and then you're going to use the process of cross-multiplying. So X times the tangent of 36 equals 1 times 4, or 4. And then X is being multiplied by the tangent of 36. To get rid of the tangent, or to get X by itself, we have to divide by the tangent of 36. Okay? So we're going to do X equals 4 divided by the tangent of 36. Remember to use parentheses around this on your calculator, or else it'll mess up your answer. 4 divided by the tangent of 36 should be roughly 5.5, and I always want you to round those to the nearest 10th unit, so 1 place past the decimal. So there's the apothem, 5.5. Okay? So I'm going to go ahead and plug that into my equation. And now I can find the area. 1/2 the apothem times the perimeter. So area equals 110, and since it's centimeters, it's going to be centimeters squared because area is always squared. Okay? So that's one example. I want you to go ahead and flip the page, and we're going to do a second example together. I'll scroll the page for you. And here's our second example. Okay? So, again, a regular polygon. So immediately I know that all my sides are the same. So area equals 1/2 the apothem times the perimeter. Okay? They gave us the perimeter, so I can just plug it in. Okay? And then the only thing I need to find is the apothem. So let's draw our triangle in here. So right down, put my right angle in, and then this segment. Okay? So remember, I have to figure out a couple of things. I need the side length, so I need to know this distance right here so that I know one piece of my triangle. So how am I going to do this? So here's what we do. We take the perimeter. If I know the total perimeter is 80, Then what I do is I divide that by how many sides there are. Since I know it's regular, I know they're all going to be the same length, so I'm just going to divide it by 1, 2, 3, 4, 5, 6, 7, 8 sides. So divide by 8 sides. 80 divided by 8 equals 10. So every side is 10. Okay? If every side is 10, then this piece is 5. Each of these is 5. Okay? So that's the first part. And then remember, of course, I'm looking for the apothem. I don't know it. And in order to use a trig function, I need to know the angle. Okay? So let's find the angle. We do that by doing 360 divided by the number of sides. There are 8 sides in this figure. That gives us 45. That is, 45 is for the entire, there's 45 8 times, but I need half of that 45. So now I need to do 45 divided by 2, and that gives me 22.5. So my angle here is 22.5. Okay, that helps. So that gives me my angle measure. So step 3 is going to be to solve my triangle. 5. I need to know my apothem, so I'm going to put my x here, and my angle is 22.5 degrees. So again, let's figure out what we have. So this is this hypotenuse side because it's across from my right angle. This is the angle I'm talking about. So across from the right angle, or across from my angle, is the opposite side, opposite my angle. And then this leaves my adjacent side over here. So just like the last one that we did, where I have to decide which of these I'm going to use, I have no information about my hypotenuse. So I'm going to cross that out, and I'm going to cross this one out because it has a hypotenuse in it, and I'm going to cross this one out because it has a hypotenuse in it. So I'm going to be using the tangent. The tangent of 22.5 is equal to the opposite over adjacent side. So again, after I fix my equal sign, 22.5 equals, there we go. I'm going to put my tangent over 1, and then I'm going to cross multiply just like I did before. So I'm going to do this. X times the tangent of 22.5 equals 1 times 5, which is 5. And then to get x by itself, I'm going to divide by the tangent of 22.5. If you do that to one side of the equation, you got to do it to the other. So the only thing I would say at this point is be really careful that when you do 5 divided by the tan of 22.5, that you put that tangent in parentheses on your calculator to make sure that it works out just right. And we should get 12.1. So there's my apothem. So now I can do A equals 1/2. Plug in my apothem, 12.1, times my perimeter, 80, that was given. Multiply it all out, and I get 484. Okay, they did not give me a unit measure in this problem, so I just call it 484. Okay, so that is the deal. You're going to find a side length or the perimeter, whichever. They usually give you one or the other. If you have the side length, you find the perimeter. If you have the perimeter, you find the side length. Once you've done that, you find your angle measure. So 360 divided by the number of sides, and then divided by 2. And then the third thing you do is use the triangle to solve for the apothem. And then you plug it into your area formula and solve the problem. So those are your steps.